We will now move on to discussing trigonometric functions. So let's start with the sine function. F of x equals to sine x. So to graph it, it looks something like that. Here we have a -1 up to 1, and this is a pi. The period is 2 pi. And you might notice that the range is -1 to 1, and the domain is all reals. We earlier learned about the horizontal line test, where we draw a horizontal line, and we noticed that this line passes through more than one point. Therefore, this function is not 1 to 1. So this function itself, we cannot uh, get its inverse. However, we can still restrict the domain and find the inverse. So if we want to restrict the domain, we would restrict it to -pi/2 till pi/2. So on our graph that we already drew, this is pi/2, and here we have -pi/2. So I will highlight this region. This region I highlighted in yellow is the region we would restrict our graph to. And this region is 1 to 1. And therefore we will find the inverse. The inverse of sine x is arcsine x. We can write that as a sine x too. This notation is the same as arcsine x, as I wrote up here. These are the three ways we can write inverse of sine x. Now the inverse will look like the following. Where this point here is 1, this is -1. Here we have pi/2, and here we have -pi/2. So the range in this case is -pi/2 till pi/2, and the domain is -1 till 1. Now let's look again at the graph we did here, at the yellow portion of the graph. For the yellow portion of the graph, our domain was -pi/2 till pi/2, and our range was -1 till 1. Now if we compare what we got here and here, so both of these domains and ranges, we can realize that the domain of the function is the range of the inverse, and the range of the function is the domain of the inverse. This is a property of inverses which we already discussed previously. Now let's move to cosine of x. So I will graph this function. It looks like this, and it keeps on continuing. So this point here is -1, up here it's 1, pi/2, here we have pi, same for here, -pi/2. So again, let's draw a horizontal line. This is not 1 to 1 because it passes through more than one point. Therefore, we will restrict the domain. We will restrict it to 0 till pi. And we can notice that the range is -1 till 1. Now let's draw the inverse. The inverse will look something like that. Or here we have 1, -1, pi/2, 0. So we can notice after drawing this inverse that the domain of the inverse is -1 to 1, and the range is 0 till pi. Again, the domain of the function is the range of its inverse, and the range of the function is the domain of its inverse. Now let's move to tan of x. The graph of tan of x looks like this, where we have an asymptote here and another one here. Again, let's draw a horizontal line. It passes through more than one point, so this is not 1 to 1. So we will restrict the domain to be -pi/2 till pi/2. And now let's draw the inverse. The inverse will look something like that. And here we have our asymptotes at pi/2 and -pi/2. The domain of our inverse is all reals, and the range is -pi/2 till pi/2. Now, we will move to a few trigonometric identities that are useful to know for this course and even future courses. So the first one, which many of you might know, is sine squared of theta plus cosine squared of theta is 1. This will be very important for us in this class. So now let's just remind you that tan of theta is sine of theta divided by cosine of theta. Secant of theta is 1 divided by cosine of theta. Cosecant of theta is 1 divided by sine of theta. Cotangent of theta is 1 divided by tangent of theta, which is equal to cosine of theta divided by sine of theta. So let's continue. Tangent squared of theta plus 1 is equal to secant squared of theta. Moving on, cotangent squared of theta plus 1 is equal to cosecant squared of theta. Sine of negative theta is equal to negative sine of theta, and cosine of negative theta is equal to cosine of theta. Now let's continue. If we were to do sine of x plus minus y, this is equal to sine of x cos of y plus minus cos of x times sine of y. Now cos of x plus minus y is equal to cos of x times cos of y. And here we flip the sign, it becomes minus plus sine of x times sine of y. Sine of 2x is equal to 2 sine x cos x. Cos of 2x is equal to cosine squared of x minus sine squared of x. Now cosine squared of x can also be written as 1 plus cosine of 2x divided by 2, and sine squared of x is equal to 1 minus cosine of 2x divided by 2. And these are all the trigonometric identities we will be discussing today. We will now look at an example that is a bit tricky. So let's look at sine of 2r cos of pi x. We would like to rewrite this without any trig or inverse trig functions. And please note that whenever you understand one type of exercise that looks this way, all the other exercises are solved the same way, so it is enough to understand one of them. And now, the way to proceed with this exercise is you first take the inverse trig function that's inside. So inside you have here arccos of pi x. You let theta to be equal to this inverse trig function that is inside the parentheses. So let theta equal to arccos of pi x. And now we would like to get rid of the arccos. What is the function that gets rid of arccos? It is in fact cos. Because if we do cos of theta equals to cos of arccos of pi x. Cos and arccos cancel each other and we are left with the pi x. And please note that theta in this case, it belongs to 0 up to pi. And now why is that? Why would theta belong to 0 till pi? Because theta is equal to arccos of pi x. And let's go back to when we learned about arccos. When we learned about arccos, we noted that the range of arccos of x is 0 to pi. So the range of an arccos function is 0 up to pi. So theta is between 0 and pi. And now what do we do with this information? We know that cosine theta equals to pi x. What do we do with this? Let's draw a triangle. We will draw a triangle where this angle right here is theta. And let's remember something we just talked about before. Cosine theta is equal to the adjacent side divided by the hypotenuse. There are other, of course, you should know the sine theta and what tangent theta is in case you got asked about them in a question. But for our question, for our sake in this question, we only need that cosine theta is equal to adjacent over hypotenuse. So we will go back to our triangle. The adjacent side is this side I'm highlighting right now, and the hypotenuse is this side. Since we know that cosine theta is pi x, this is the same as writing pi x divided by 1. So, since cos of theta is adjacent over hypotenuse, we set our adjacent side to be pi x, and we set the hypotenuse to be 1. Now, we still have one missing side, which is the opposite side. What do we do with this side? We let this side be c. C is an unknown for now. Now let's solve for c. And we all remember the Pythagorean theorem, so let's use it to solve for c. So, using the Pythagorean theorem, the hypotenuse squared, or 1 squared, equals to pi x squared plus c squared. So let's solve for c squared. C squared is equal to 1 minus pi x all squared. So c equals to the positive or minus the square root of 1 minus pi x all squared. And you will notice that c is the length of a side, so c is positive. Therefore, we accept the positive answer, so c is equal to square root of 1 minus pi x all squared. Now, the question does not ask us for c. The question is asking for sine of 2 arc cos of pi x. So let's write this down. Sine of 2 arc cos of pi x. And we already said that arc cos of pi x is theta. So the question is asking for sine of 2 theta. Now we learned before identities regarding sine of 2 theta. This is equal to 2 sine theta times cos theta. So now let's get rid of the trig. So let's get rid of sine and let's get rid of cosine because this is what the question wants. So instead of sine theta, let's find sine theta. Sine theta is equal to opposite over hypotenuse, and the opposite side is here. It's c. And the hypotenuse is 1. So sine theta equals to c over 1, which is equal to c. Let's write this down below. And now let's find cos of theta. Cos of theta, we already found it here. Cos of theta, we already said that it is pi x. So let's write this here as well. Now, instead of c, we already found what c is. We already agreed that c is the square root of 1 minus pi x all squared. So let's write this down. So our final answer is 2 square root of 1 minus pi x squared times pi x. And this is our answer.